Hey, what's up? This is Madan sir here, and I'm back with another very important, conversion. And this time I'm talking about not just conversion, I'm also talking about the, preparation of carboxylic acid. And this involves two very important, reaction. One is called how you can convert, an anhydride into carboxylic acid, and another is, how you can convert an ester into carboxylic acid, right? So there are some reaction and they are definitely going to be easy, but at the same time they are really important, so you need to pay attention to that, right? So let's go to the equation part here. So what this is, something like, I already said you that we are converting an anhydride to carboxylic acid. We are converting this anhydride into carboxylic acid, right? So the two examples that I need to do is from the NCERT. So every time you study from NCERT, you definitely will have a help from, once you watch all these, right? So what this is about, and this is about an anhydride. It's called benzoic anhydride. So what this benzoic anhydride is, let's see that. So you have a benzene here, and on the benzene you have a carbonyl group, and on the carbonyl group you have an oxygen. Then there is another carbonyl group, and this carbonyl group is again attached with the, benzene here. So this is what the benzoic anhydride looks like. Let me write this. So this is your benzoic anhydride. Now, how you can convert them to carboxylic acid? The process is called hydrolysis. Right? What hydrolysis means? You react, an anhydride with water. But a water has very important thing that it dissociates into two ions, which is H plus and OH negative. Right? Now let's go through the reaction part. I'm taking a very short method, and you don't have to go to the in-depth mechanism of the reaction. What this is, you have a single bond right here and a right there. You cannot cleavage this bond because this has a partial double bond character. This also will not break. So, and this one, this one is again very impossible because they have a double bond as well. So these are the two bonds where the bond can be broken. So you can break either of them. Let's say I'm breaking this one. So what will happen if you break this bond? Oxygen being electronegative will develop a negative charge, and this carbon will develop a positive charge. So this is what is going to happen. You have, this positively charged part, and you have, this negatively charged part, right? Now, just interaction is important between the hydrogen ion, which will go with the oxygen, and this hydroxide, which will go with the carbon. So that's how you will get the two products. So what the products are going to be? The products are going to be benzoic acid. What this benzoic acid is? You had carbon, a carbonyl group, and you had oxygen. You had a hydroxide ion, right? And then, another one, just concentrate here. This oxygen will react with H plus. So this will also convert into, another anhydride. C double bond O and OH. Let's take another example of anhydride to carboxylic acid, where I'm, taking, suppose this is, a benzene here. The benzene reactor, the benzene is having this, this is what. So what this time is, you have an ethoxy here. It was initially, a benzoxy, but this time, there it was a benzene, but now I have changed it. You can take any example you want. Suppose I'm taking this one. So in case you have this reagent, what will happen? They react with water, and when they react with water, the water produces the two ions, H plus and OH minus. Now you can break this bond or this one. Let's break any of them. So what will happen? O will form a negative charge and carbon will form a positive charge. So OH will go with the carbon and H will go with the oxygen. So in that case, you will form a benzoic acid. This will form a benzoic acid, and other will form a ethanoic acid. So this is what your products look like. And the other one will form a ethanoic acid. This will form a ethanoic acid. I'm not paying importance to the hydrogen here. So this is how you can do, any anhydride conversion to carboxylic acid, right? We have another very important equation from NCERT, and that is, how you can convert. So what we have now, we have an ester, and we are converting the ester into carboxylic acid. Carboxylic acid. Okay, so what an ester is, you can take any kind of ester you want, but there is one very important, in acidic hydrolysis, ester directly convert into carboxylic acid. Carboxylic acid. But in basic hydrolysis, this first convert into salt, and then further hydrolysis convert the salt into carboxylic acid. Carboxylic acid. So let's follow the two different conditions we have and see how the reaction takes place. So what I'm taking here, I'm taking any ester possibly we can take. So I'm taking an ester based on, benzene. So this is how it looks like. Right? So this is an ester here. Now, this ester is characterized by presence of, COO attached to the alkyl or aryl group. And what you are doing, you are reacting this water in presence of acid. So what will happen, like you do know that it produces the two ions. So when you are using acid as a medium, what will happen? This will directly convert into carboxyl. So let's see how this happens. You have an option, you can break only this bond because this has a partial double bond, and this also has a partial double bond. So you just break this bond. So this will become a negative charge and carbon will form a positive charge. So what you can do, attach the OH to the carbon and you will get a benzoic acid. And what else you can do? You will get a phenol. Why? Because this hydrogen will show an interaction with the O. So this is these are the two products. One is your benzoic acid, another is the phenol. So let me repeat back. If you react, if you make the ester undergo hydrolysis in presence of, acid, this gives a mixture of alcohol and this gives a mixture of alcohol or maybe phenol along with carboxylic acid. So this is very useful one, right? You will get two different products when you perform an acidic, hydrolysis of ester, right? This is something you've been studying from your 10th standard and all. Let's take another example where I'll be talking about the basic condition. So I'm just taking any example here. Suppose I'm taking this one. Right? And what you have water, but this reaction is taking place under basic condition. So under basic condition, what will happen? First it will convert into a salt. So how are you going to do? You need to use a base like NaOH. So you do know that this has a negative and a positive ion as well, apart from water which has H plus NOH. So what I will do, I'll let the bond go cleavage right from here. I will make this bond undergo cleavage. So sorry, this one, because this is a bit stronger as compared to this one. So I will break this bond. So what will happen? This bond will will undergo cleavage like this. So this become a negative charge and carbon become a positive charge. So in that case, sodium will attach to the oxygen and it will form. Should I wipe this off? So in this case, the sodium will form a salt. The salt is called sodium propanoate. This is called sodium propanoate. And other product will be this carbon. You need to understand that this carbon will result formation of a methanol. So you get CH2OH, CH3OH, sorry, CH3OH. So you get a methanol as well. Methanol. But in order to produce, this salt into carboxylic acid, what I will do? I will make this undergo hydrolysis. Right? Hydrolysis again. So due to the hydrolysis, the sodium will be replaced by the hydrogen and then this will become a carboxylic acid. So you get your propanoic acid. Right? So this is what I wanted to do in today's lecture. Let me repeat back here. If you let the ester undergo hydrolysis in acidic condition, it will directly convert into carboxylic acid, but you also get another product of alcohol and phenol depending on the reagent. But if you let the reaction undergo hydrolysis in presence of base, you will first convert into a salt and then the salt will undergo hydrolysis to produce the carboxylic acid. But there again you also get the alcohol as well. So alcohol is also one of the major product here. So what's the advantage here? For ester hydrolysis we have ester hydrolysis produce not only carboxylic acid but also an alcohol, but anhydride hydrolysis only produces 2 moles of carboxylic acid, right, depending on the reagent. So this is where I need to complete this. I would say thanks for watching, right.